In this video, we are going to discuss basics of functions and relations. We will distinguish between independent and dependent variables. We will define and identify relations and functions. We'll find domain and range of relations and functions, as well as identify functions defined by graphs and equations. So independent and dependent variable, we often describe one quantity in terms of another. For example, the amount of your paycheck depends on the number of hours you worked. The distance traveled by a car depends on the time it's been going on the road. Relations and functions. Relation is a set whose elements are ordered pairs, whose elements are relations between two different quantities. So relation is a set whose elements are ordered pairs. Function is a special kind of relation in which each input has exactly one output only. That means no two x values should be repeating. It's okay for the y values to repeat. Determine if each relation defines a function. So first example, we only need to worry about the x values. Each x value is different, so yes, it's a function. Second example, for the set B, each x value is different, so we would say yes, it's a function. For the third example, we do have repeating x values. So x values are repeating, that is not a function. Input values are repeating, it is not going to be a function. So the condition function is a special relation where each input has exactly one and only one output. One input cannot be connected to two different outputs. Okay. Relations and functions can be defined in several ways. We can write them as set of ordered pairs, as correspondence or mapping, as a table, as a graph, or as an equation or rule. Correspondence or mapping, if I have the set A as 1, 1, negative 2, 4, 3, negative 1 are the elements, we can say 1, negative 2, and 3, and 1, 4, and negative 1. So we can show them as a mapping. Relations and functions can be represented as correspondence or mapping. We can also represent them as negative 2, negative 1, 0, 1, 2, negative 1, 0, 1, 2, 2. So another example of correspondence. Tables and graphs, so we can represent x is 1, y is 1, x is negative 2, y is 4, x is 3, y is negative 1. So x is 1, y is 1, x is negative 2, y is 4, x is 3, y is negative 1. So we represented it as a graph now. If we connect the dots, that would be graph of a function. Equations or rules. A relation or a function can be described using a rule that tells us how to determine the dependent variable by using a specific independent variable value. For example, y is equal to x plus 2. So if I know, I can input any value for the x here and I would be able to get an output value for the y. So it's a special rule which is called equation. Another example can be y is equal to 3x. Another example can be y is equal to negative 1/2 x minus 5 plus 11, something like that. So each input value we put in here, we will get a different output value. Domain and range of relations and functions. Domain is the collection or set of all the x values or input values. Range is collection or set of all the output values or y values. So domain and range of this relation, if you're looking at this relation, the domain would be all the x values, 1, negative 2, and 3. Range would be collection of all the y values, 2, 4, and negative 1. Give the domain and range of each relation. So we are given some relations, we're looking for domain and range. Domain and range. Domain will be all the x values. We have x equals 0, negative 1, 1, 4, and the y values would be the range, which is negative 1. We can write them in the order negative 3, negative 1, 1, 2. And for the next one, domain would be all the x values. In this case, we go from negative 3 to 3. And the range, brackets means everything inside is included. So x values between -3 and +3, including -3 and +3, are my domain. And range is the y values, which goes from -5 to 5. Give the domain and range of each relation. So for the part C example, domain is going to be the arrows are going in both direction. So domain is all real numbers going from -infinity to +infinity, and range is also all real numbers going from -infinity to +infinity. Next example, domain is the x values, and since I have the arrows going up, that means all the x values will be taken by this graph at some point if I extend it. So domain is between -infinity to infinity, all values. Range is, so this is my -3, so it only goes -3 and above, does not go below -3. So range would be -3 to +infinity. Infinity always gets parentheses because we don't really know where it's at. So it's not a real number. It's not a number that exists. So -3 to infinity with -3 will have bracket around because -3 is a part of the y domain, part of the range of this function. -3 as a y value is taken by this function. Identify the function defined by graphs and equations. So to identify it as a graph, we use the vertical line test. If the graph passes the vertical line test, then it's a function. If it does not pass the vertical line test, then it's not a function. So anywhere on your graph, if you draw a vertical line, this is going to fail the vertical line test, so it's not a function. On this graph, you can draw a vertical line anywhere, and your vertical line should not touch the graph at more than 1 point, so yes, a function. Another one, again, you can draw the vertical line anywhere. Your vertical line will not touch it in more than 1 point, so yes, a function. And the next one, if you draw the vertical line, your vertical line touches the graph at 2 different points, and that means it's not a function. The thing here that's happening is one x value is connected to 2 different y values. That's the issue, and that's why it is not a function. The x value -1, I'm just going to call it -1, is connected to 2 different y values. So there's a point -1, 5 on your graph and -1, -5 on your graph. And that's why it fails the definition of function. It's not a function because your input values are repeating. Use the vertical line test to decide whether the given relation is a function or not. We can draw the vertical line wherever we want, and we're going to say, yes, our vertical line does not touch the graph at more than 1 point. Same thing for the next graph. We can draw the vertical line anywhere, and it is a graph of function because vertical line does not touch it at more than 1 point. So next problem, decide if the given equation represents y as a function of x or not. Hint, we're going to solve for y. For each input value x, there should be exactly one and only one output value y. That means one x should not be connected to 2 different y's. So let's go ahead and solve for y here. When I solve for y, it's y squared is equal to 8 minus 4x squared. Y is equal to plus minus 8 minus 4x squared. And that makes it not a function. This is not a function because one x is connected to more than one y. So this would be not a function because if x is equal to 0, we can make a table. If x is 0, y is going to equal plus minus square root of 8. So there's 2 values of y which are connected to same x, and that's not okay. Example number 2, let's go ahead and isolate the y. So y is equal to 4 plus 3x squared. This one, each x is connected to each unique y. So it's going to be, yes, a function because we can go ahead and make a table. Each one x will be connected to exactly and only one y here. Next, x equals y to the 4th. Y is equal to plus minus 4th root of x. Again, this would be not okay because if x is 0, then you're connected to 2 different y values here. So not a function because of the plus minus in the front. Y is equal to square root of x minus 3. Yes, a function because each unique input will give you exactly and a different unique output. One output will be not connected to more than one input value. X's will not be repeating here. So if you go ahead and make a table. Next one, we have absolute value of y is equal to 3 minus 6x. This one, if x is 0, let's see what is y equal to. So if x is 0, y can equal 3. But if x is 0, y can also equal negative 3. So one x value is connected to two different y values. So that is not a function. Next one, similar to the first problem, y is equal to plus minus square root of 16 minus x squared. Not a function because one input values are repeating here. When x is 0, y can take two different values for x as 0. Y is going to be positive root 16, which is 4, plus and minus 4. Because if x is 0, y can be positive 4 or y can be negative 4 because of the plus minus sign in the front.